Okay, folks, here are the answers to the 2016 free response questions. We've done them once, but we're going to take a look at them again. So I'm going to read the information here that water is pumped into a tank at a rate modeled by the following equation. So this is our rate going in. And this happens between times 0 and 8, where t is measured in hours. Water is removed from a tank, modeled by the equation above. Here is the out equation, out, where r is a differential and equation that's decreasing between t0 and t8. It says select values of r or t are shown in the table above. At time t0, there is 50,000 liters in the tank. That's our start. So they've given us one rate as a function, well, two rates as a function. One is a table of values, which we'll be able to work with. One is a regular function, which we'll be able to work with. And the starting time. First thing it asks you to do is estimate r prime of 2. R prime is a rate. When we estimate rate, we're going to fib faba. R prime of 2 is going to be, well, r prime of 2 is going to be somewhere in here. So it's going to be 950 minus 1190 over 3 minus 1. I could stop there. I made one mistake on purpose. Do you see it? Yep, it's not that r prime of 2 equals that. It's that r prime of 2 is approximately that. So I could leave it like that. If I really wanted to simplify it, it does simplify down to negative 120. But here it says, make sure I show units of measure. Well, all I have to do is look at what the original graph was, which was liters per hour. Liters per hour. And because I just took the derivative, I'm going to add a kitty cat, liters per hour squared. Okay, let's take a look at B. B says use a left Riemann sum with 4 subintervals to estimate the total amount of water removed from the tank. Well, first of all, will that work? I'm starting with a rate. If I integrate the rate, correct, I get a quantity. So 1340 is the height times the width, which is 1, plus 1190 times the width, which is 2, because from 1 to 3 is 2, plus 950 times 3, so that's the width of that one, plus 740 times 2. We can put all those in our calculator, and we would get a final answer of 8050. Did it ask me for unit of measure? No, it does not ask me for unit of measure, so I'm not putting one down. Did this overestimate or underestimate? Well, remember, if I think about the picture is decreasing. It goes like this. A left Riemann sum will overestimate, and they ask us for reasoning. My reason could very simply be I could draw a picture of a Riemann sum with a decreasing curve and show it just like that, or I could say that the left Riemann overestimates a decreasing function. So the next part of the question asks the following. It says, use my answer in the last part to estimate the total amount of water in the tank at the end of 8 hours, which is kind of where they were directing me to the whole time with this question. Remember, the total amount is going to be equal to, total is going to be what you start with, plus the integral of what goes in, and the integral of the rate that comes out. You have the rates, you just integrate them away. So, do I know how much I started out with? Yes, I do. I started out with 50,000. Do I know how much went in? Yes, because they gave me the rate that went in. So if I integrate from 0 to 8 of W of t, I can have to hit my calculator, dt. Do I know it went out? Yes, I know that the amount I had just had is what came out, 8050. Now let's say you got this number wrong in the problem. As long as you use the same number there as here, you will get full credit on part C. And if I combine all those things together, put it in my calculator, I get 49786.19532. They always want me to round to the thousands place, so I'm rounding to this place. So I'm going to end up with a certain number of liters, except I'm going to just double check my question here. Unless they tell me it says to the nearest liter. So I'm going to dump all the decimals, because that was a 1 right there, and I'm going to say it's 49,786. Does it say right unit of measure? No, it does not. So guess what I'm not doing? I'm not writing the unit of measure. Okay, now the last spot says for time 0 to 8, is there a time when the rate in which the water is pumped into the tank is the same at which the water is removed from the tank? Why or why not? Okay, well, what we're going to do is we're going to just compare the two. And this is the challenging part of the problem. It usually comes down to something like the intermediate value theorem, which says that the rate of the original function went between 1340, rate of the original went between 1340 and 700. And if I put the numbers in my other function, I will get that they have a height of 2,000. If I put them into here, if I find the rates at 0 and 10, this one was at 2,000. And this one was at 81. So anytime you're trying to prove that a number had to exist, well, I know to get to 81, it had to go through all of these values. And to get to 700, it had to go through all of those values. And because the 2,000 had to pass everywhere between 1340 and 700, at some point they had to meet. So we can just say, you can always pick an answer. We can say yes. And the reason is intermediate value theorem. You can put just that much down. It'll get you full credit for the problem. So that's any time they ask you to kind of prove that something exists, why or why not. The intermediate value theorem, which says you have to pass through every number, is a good way to do so. Okay, let's take a look at number 2. Okay, for this one we have a particle moving on an x-axis, so it's going to be rectilinear motion. They gave me an equation for velocity of the particle, and they gave me a specific position at a certain time. It says at time t equals 4, is the particle speeding up or slowing down? Well, the only way to tell if something is speeding up or slowing down is to check the velocity and the acceleration. Well, I could put 4 right into my velocity equation on my calculator, and I get 2.9782, which all I care about is a 8772, sorry, is a positive number. If I use my derivative function on my calculator, I'll find a function for the derivative of velocity, and then I'll put 4 into that equation. If I put a 4, I will get negative 1.164, which is a negative value. Therefore, it is slowing down. The other way I could have done this is I could just graph this thing right here and trace it to t equals 4. If I do so, you would see the value of that graph, which is v, is positive, and the slope of the graph of a is negative, indicating the same thing to me there. Okay, part B says find all times over the interval when the particle changes direction and justify my answer. So for part B, when do I know it's changing direction? Well, when I have a v that's 0 and the graph goes from positive to negative, it does ask me to justify my answer. So I'm going to look at this in the calculator, and when I look at the graph in the calculator, I can see that there's one time where it changes direction, and that's at t equals, I just went to the graph of v and find anywhere where the v was 0. So that was at t equals 2.707486. And I had to check what happened at that point. Well, it asked me to justify. I can say I used the calculator. And v was equal to 0 and changed sign. I can write that way. I can write out from positive to negative and negative to positive. I can mix and match the words as long as I'm saying that they change signs. So to find the position, which is in part C, position is going to be displacement, I need to know where I started and how far I walked. Well, knowing how far I went is pretty straightforward. I'm going to integrate from 0 to 4 the function v of t, and that is going to be equal to negative 5.81527. Just putting the function into the calculator. So that's how far I went, but it says what's my location? Well, I started at time 0, I was at 2. So at 4, I will be at 2 minus 5.815027, which is equal to negative 3.81. They want me, 815, right. You guys had them rounding to the thousands place. Negative 3.815. And the last part of this problem is total distance traveled. Remember, distance and displacement are two different things. Distance is just equal to 3, the absolute value of the integral velocity. So once again, displacement is just the integral of velocity. Distance is the integral of the absolute value of velocity. If I put that in my calculator, I get 5.301244, rounding to the thousandths place. So the answer is 5.301. None of these ask me for units of measure. I'm not giving them back units of measure. Okay, question 3 gives me a graph of f. And the figure shows a piecewise linear function for f. G is defined by this integral, which means I'll probably have some sort of drop the top and finding area under the curve. So the first thing asks me, does G have a relative minimum or a relative maximum at x equals 10? To look at mins and maxes, I'm always going to look at derivatives. So the derivative of G is, drop the top, G prime of x equals f of x. So remember that f of x is our values of the graph. So to talk about G prime, I want to talk about what happens at 10. At 10, G prime is equal to 0. Before 10, G prime or f has negative values. After 10, G prime or f still has negative values. So there is no max or min. You could put this graph there and point at it. You could say because U-B-E-C-A-U-S-E. Okay, so it says, does the graph of G have a point of inflection at x equals 4? So points of inflection for G would involve G double prime of x, which is equal to f prime of x. So G double prime will be the derivative of f. So let's make a table of values for G double prime. So G double prime would be the slopes, and we're looking at x equals 4. So when x equals 4, the slope is undefined. The slope before is positive. The slope after is negative. Therefore, yes, 4 is a poi. And when they ask me to justify my answer, I can say because G double prime of x, by the way, this is concave up and concave down for G. G prime of x is undefined and changes from positive to negative. And that's the magic word, it changes from positive to negative. Anytime you ever justify your answer, if you're not sure what to do, just say yes or no and say because something changed from positive to negative. You might actually get full credit for it as you're working on it. Okay, so the next thing says find the absolute minimum and the absolute maximum of the values of G on this function. So I'm going to go back to my original statement about G. G is equal to the integral of f of t. So I know I'm going to be involving areas and areas under the curve to find the values for G I'm going to have. So they asked me to look between negative 4 between -4 and 12. So if I'm going to be doing that, I know I'm going to do first, I'm going to find all the areas under the curves. Okay, so I found the values of the area under the curve moving from left to right the whole time. That's why some are negative and some are positive. When I come up with the table of values for here, though, I have to be careful about knowing which direction I'm moving, but it's pretty easy to do. The first thing you do is evaluate the integral from 2 to 2, because I know when x is 2, the integral from 2 to 2 is 0, because I didn't add any area. Once I'm moving past 2, when I head in the positive direction, I'm going to do exactly what it says there. I'm going to add those values on. Now, I did more than I had to. I didn't really have to break those into smaller intervals, but I did. So from 2 to 4, I'm adding 4 more. From 4 to 6, I'm adding 4 more. From 6 to 8, I'm subtracting 4. I should say 8. From 8 to 10, I'm subtracting 4. And from 10 to 12, I'm subtracting 4. Hey, Quint.
Hey, Dad, me and Sam are leaving for school.
Okay, have a good day.
Love you.
Bye. Oh, my graph is still going. So you got to hear me talk to Quincy. Sorry about that. I thought it was paused. Okay, so when is this graph less than or equal to 0? Well, between 10 and 12, and between 0 and -4. So if I was to write those down, it doesn't ask me to justify. I'm going to say that when x is between -4 and 2, the graph is less than 0. And between 10 and 12, the graph is also less than or equal to 0. That's enough proof to put on there to keep it. I'm going to save this one and record the next.